We had studied what are physical and chemical changes. Also we had studied what is chemical reaction along with its components, reactants and products. Today we are going to study what is chemical equation and its type. Also we are going to study what are the observations for a chemical reaction that tell us that a chemical change or reaction has taken place. Now what's a chemical equation? Chemical equation is a shorthand representation of a chemical process, either in terms of words or symbols and chemical formula of the substances. Now in terms of words, what? Names of compounds or elements are written, and in terms of symbols and chemical formula is what? Instead of names, we are writing the symbols for elements and chemical formula for compounds. So we'll find that its whole process, which can be given in words in a long way, that can be written and spoken in a very small manner. In a shorthand representation we can give, that is known as chemical equation. For example, a reaction between zinc and hydrochloric acid releases hydrogen gas along with formation of aqueous solution of zinc chloride. We'll find that instead of speaking long statement, a reaction between zinc and hydrochloric acid give us products zinc chloride along with the evolution of hydrogen gas. We'll see, instead of saying this much long sentence or a statement, we can write zinc plus hydrochloric acid with an arrow in the center that tells the process is going towards the products, that zinc chloride and hydrogen are the products here. So we are writing reactants on left hand side and products on right hand, reactants on left hand side and products on right hand side. So this whole statement can be given in a brief manner, which is known as chemical equation. Instead of giving the names of compounds and elements, we can write the symbols for elements, like zinc can be given as Zn and hydrochloric acid can be given as HCl. So zinc chloride form we can write ZnCl2 and hydrogen as H2. Now chemical equation is of two kinds. That's the word equation and chemical equation. As I already told, in word equation we are writing whole process in short manner, that's in with the names of elements and the compounds. Already seen the example of zinc plus hydrochloric acid giving rise to zinc chloride and hydrogen. Another example, magnesium plus oxygen gives magnesium oxide. Now we will see the chemical equation, in which we are writing symbols for elements and chemical formula for compounds. So instead of saying symbolic, I just written this, but it is generally called as chemical equation. So chemical equation, usually wherever we are going to write and speak in our other chapters, there will be writing all the elements in the form of symbol and all the compounds in the form of chemical formulae. So this is the chemical equation. So as seen the example, zinc plus hydrochloride, hydrochloric acid will be writing Zn plus twice HCl give rise to ZnCl2 plus H2. This shows zinc and hydrochloric acid are reactants and zinc chloride and hydrogen are the products. Similarly, magnesium twice Mg plus O2 give rise to twice MgO. That shows that Mg reacts with magnesium, reacts with oxygen to give magnesium oxide. Many more examples we can give. What an information a chemical equation gives to us. It tells about what are the reactants and products. On left hand side we are writing always reactants. On right hand side we write products when the reaction carried out forward. It tells us physical states of substances. Like see here in examples, before zinc, S is written in solid, that show S is written for solid, that that shows zinc is a solid. Similarly, hydrochloric acid, AQ is written bracket, which shows that it is an aqueous solution. For gases, we write G. For liquid we write L in bracket. And if gas is evolved as product, then we write up arrow before it. So it shows what are the physical states of reactants and products in a chemical process, in a system. It also gives us what are the number of moles of substance. As you see in first example, HCl, before HCl we have written 2. This 2 is a stoichiometric coefficient which shows how many moles of hydrochloric acid are required to react with 1 mole of zinc. Similarly, in another example, before magnesium 2 is written. So 2 moles of magnesium are required to react with oxygen, and 2 moles of magnesium oxide are formed. So we'll see that it gives the number of moles of substances also. If we see, it also tells us about the reaction condition. In second example, see, magnesium burns in presence of oxygen. So 1 is written. If heat is required, then either a symbol of del or heat is written over the over the arrow. Similarly, if any pressure condition is there, any catalyst is required, or anything else like some other medium instead of water is required, like ether is required, reaction is carried out ether or dry ether, acetone. All these are the reaction conditions which shows that either what is the media or what is the temperature, pressure conditions, all these, or what is the catalyst required. Catalyst is the substance which increase the rate of reaction. Sometimes it happens that reaction doesn't take place, so catalysts work out there. For example, in our digestion, you have studied that we are having enzymes like salivary amylase, pepsin, trypsin, chymotrypsin. What are these? These are biocatalysts. As they are working inside the body, they are catalyzing, they are increasing the rate of reaction of biochemical reaction taking place in our body. So they are called as biocatalysts. So if they are not present in our body, once we take meal, it will take about 50 years to get digest. So they are increasing the rate of reaction so high that after 2 or 3 hours we feel that we should eat something. So catalysts increase the rate of reaction. They are those substances. So here we will see that information given by one more condition is information is given, that is whether the reaction requires heat, that means absorption of heat takes place, or whether the heat is evolved. In first case of zinc and hydrochloric acid, you see heat is evolved. I have written on left hand side. So when heat is evolved, right hand side. When heat is evolved, then that is written on product side. When heat is required, that is written on arrow to show that reaction requires increase in temperature. So that's why heat is supplied to the system. So just summarizing, it informations given by a chemical reaction equation, that's the reactant and products, what are the physical states of these substances, and what are the moles, number of moles of substances required, what are the reaction conditions, whether the heat is evolved or heat is absorbed. Now we will see what are the observations that shows us the reaction has occurred. Now this can be seen by the evolution of gas. For example, when zinc reacts with hydrochloric acid, it gives zinc chloride and evolution of hydrogen gas. Here you see in attached activity, in attached video, we'll find that hydrogen is getting out of the vessel, it evolving out of the vessel in the form of bubbles. The reaction starts, hydrogen is bubbled out. Now we'll see another example for evolution of gases. That's the evolution of carbon dioxide when acid reacting with sodium carbonate or sodium hydrogen carbonate. Here we still see the activity. There are two test tubes taken. In one test tube, cork is fitted with delivery tube and thistle funnel. In test tube, sodium carbonate is taken and hydrochloric acid is poured in this test tube with the help of thistle funnel. Another end of delivery tube is kept in another test tube in which lime water is placed. This lime water turns milky and carbon dioxide comes out as brisk effervescence. Brisk effervescence means what? When you open the soda water bottle or you pour ENO in the water, you find the bubbles that coming out so briskly. That is brisk effervescence. So here lime water turns milky due to formation of calcium carbonate. Now we'll see that reactions are accompanied with formation of precipitate also. What is precipitate? An insoluble solid substance formed when the aqueous solution of two ionic compounds are mixed, like sodium chloride and sodium sulfate and barium chloride. Their aqueous solution are colorless, and when you adding together in very few milliseconds it turns white due to formation of white precipitate of barium sulfate. Similarly, when we have seen in last activity when carbon dioxide is passed through lime water. So calcium carbonate turns the lime water solution milky due to formation of white PPT of calcium carbonate. We'll see that precipitate is denoted by a down arrow because solid is formed. It is insoluble solid. PPT is insoluble solid. Now when we keep the vessel for long time, we'll find that this insoluble solid, which is called as precipitate, is settling down in the bottom of the vessel where the reaction is carried out. We'll see that this. So what is the definition of precipitate? Insoluble solid substances form when two solutions are mixed, ionic compound solution is mixed, or when gas is passed through an aqueous solution of a compound. Such reactions are called as precipitation reaction. We'll see the activity, the reaction between lead nitrate and potassium iodide. Both the solutions are colorless. A yellow PPT of lead iodide is formed which turns the solution yellow. You see dropwise Ki is added which is colorless. Lead nitrate is also colorless. It is added dropwise. As the drop falls in the lead nitrate, we'll find that solution turns yellow due to formation of lead iodide. See, with each drop the yellow color increases, intensity of yellow color increases. If you keep that vessel for long time or test tube for long time, you will find that this insoluble PPT settles down. Now we'll see the change in color. Already in last activity we have seen lead iodide is formed which changes the color of two solutions from colorless. When they are mixed, the solution turns yellow. Similarly, we had seen the reaction between carbon dioxide and lime water. We had seen the reaction between sodium sulfate and barium chloride, colorless solution mixed, and we had a white solution. Another example, that if an iron nail is kept in blue solution of copper sulfate, the solution turns pale green due to formation of ferrous sulfate, which is pale green, and also there is deposition of copper over the iron nail. Will find shiny silver grey color turns to the brown. So there is a change in color to some reactions. We'll find in some reaction change in state is also. In last activity we have seen the two solutions were liquid, lead nitrate and Ki. Now yellow PPT is formed, that is insoluble solid. The change in state is there. If lime water taken and carbon dioxide is passed, carbon dioxide is gas, lime water is liquid, but we are getting a solid compound calcium carbonate which settles as a precipitate. Reaction between zinc and hydrochloric acid also we have seen, where the hydrogen is evolved. So zinc is solid, hydrochloric acid is liquid solution. We'll find that case is evolved. So though the changes in color and state are said to be physical changes, we find that in some chemical reaction these physical changes also indicate that the reaction has taken place. These are the observations. Now another change that we see is the change in temperature. This change in temperature means reactions have either increase in temperature or decrease in temperature due to evolution of heat or absorption of heat. On the basis of this evolution and absorption of heat, temperature changes, will find that reactions are of two kinds, that's the exothermic and endothermic. Exo means outside, external, that the heat is being evolved. Similarly, endothermic, internal, heat is taken in, supplied to the system, or heat is absorbed by the system. Exothermic, as I told, heat is evolved. So here we will find there is increase in temperature. So we will find there is rise in mercury level of thermometer is kept in the vessel. So example, like when you burn coal or LPG or methane gas or any other fuel, we'll find they burn in air to give carbon dioxide. If it contains hydrogen, then obviously it will give water also, like methane burns, so it gives carbon dioxide and water. I had taken example of coal. Here carbon dioxide is formed. Energy is released in the form of heat and light here. So heat is evolved here. During winters we have the fire around us. We lit the fire to keep us warm. Similarly, zinc and hydrochloric acid react, the vessel becomes hotter. Another example, that reaction between acid and alkali. Now here see in Attesh activity, fuel burns, it gives heat and light both. Reaction between acid and alkali, that is neutralization, evolves heat. Calcium oxide, when water is poured, respiration, here heat is evolved. See here in activity, reaction between sodium hydroxide and hydrochloric acid, will find that there is increase in temperature due to evolution of heat. Mercury level of thermometer rises. Now we'll see other examples, that burning of fuel and zinc and hydrochloric acid. We see endothermic reactions, heat is absorbed by the system. There will be decrease in temperature. So sodium carbonate, when treated with ethanoic acid, it requires heat, and will find that sodium ethanoate is formed along with the formation of water and release of carbon dioxide. We'll see through an activity. Other examples are electrolysis, photosynthesis. Now see here, thermometer, mercury level decreases. That's all for now. We'll be studying balancing of chemical equations in our next class. Thank you.